Hello everyone, today I am going to deliver a lecture on bolt and weld connection. If the lecture is going to so much long, then I will not uh, I will exclude the weld connection, but I will focus on the bolt connection design. Uh, Okay, so let's start. First of all, I will start the bolt connection design. If I'll get the more time, then I will also deliver the weld connection. So let's see. Here's some basic theory. What is the residual stress? Residual stress are self-balancing stress that remain in member without application of load, and it has been formed or rolled in a fascinating. Okay. So we can see here is the source of residual stress is four source. We can see one is uneven cooling which occurred after the hot rolling of structure. Another is cold bending or cambering during the fabrication, and another is punching holes and cutting operation during fabrication and welding. Okay, so you can see here is the another connection is rebate. So if we see, we can see the picture is given here, the rebate picture. uh, okay, so if we how we'll get when the rebated inserted, after the inserted rebate and then hammering the hammering and the other hand other ends, and this form is forming. Okay, what is the difference between rebate and bolt? Rebate is a metal of the connection member of joint by inserting ductile metal pin into the hole of pieces being the joint and forming ahead of the each of the prevent joint from coming apart. And two is rebate is required to a crew for four or five experienced person. On the other hand, the crew required for high strength bolt is installation do not need to hire skill. And then we can see the inspection was difficult, and cutting and outing replacement and bolt rebuild was expensive produce, and even the pheno pre-headed immediately prior to driving in the critical and developing necessary tightness after the cooling. And then we can see the principal alpha factor that deploying immediate uh, acceptance of high strength bolt was high cost of the material, including two hardened waster in the early 1915. The reduced the labor cost for installing bolt did not offer the higher bolt material cost. And then we can see after the washing could be reduced the one or climate and the greater strength climate climate and the greater strength bolt over heat and the river could be utilized in design, and higher strength bolt require the economic. And now with the even higher labor cost and the connection design greater required to the fewer bolt than would be required for rebate, and economic is clearly with high strength bolts. So let's see, here is some ASTM 36 between ASTM 36 and 32.5. 36 mean Fy equal to 36 and Fu equal to 56, and 325 is 90 and Fu equal to 120. ASTM 572 which is 50 get Fy 50 and Fu equal to 65. ASTM 449 490 equal to Fy F 120 and F50. So we are seeing in the bolt ASTM 36. Usually we have been use 90 grade, and ASTM 36 which is 36 is usually yield distance as 36 and ultimate equal to 58. Okay, we can see here is a bolt, here is a head and struck, and the thread length we can see here, here, and the total bolt length you can see. This is the nut we can see. We can see number one, if we tension in two end, then the this type of stress is occurred, and the shear is occurred this to these two surfaces. And this is the another phenomena when bolt 1 to the tearing. Here is a possible failure mode of bolt connection. Here is a three type of failure: is of shear failure, bearing failure, and tensile failure. So let's see the shear failure. You can see the shear failure is occurred. Here is a bolt and shear failure. And after the shear failure of plate, so you can see the plate will be fair. And the shear failure of bolt will this bolt and this bolt is fair shearing fail. And the plate shear the plate fail. We can see here. And the bearing plate, we can see the bearing failure at bolt in bearing. When the bearing fail at the bolt, we can the physical appearance here. And the bearing plate, if the bearing failure in plate, the phenomena will be occurred like this. And the tension failure, you can see here the tension when the bolt will be failure in tension zone, so this phenomena will be occurred. And that tension failure, if the tension failure occurred in the plate, then the phenomena will be occurred like this. So you can see here the tension is turning here. So we can see DAC is the this whole dia, and D by 2 is here, and LC, which is the clear distance. We can say the clear distance between two hole. This is the LC, and another LC is two distance between two hole of the surface. So here is some shortcut formula of the bolt I have been taken here. So limit state bolt and bearing, tearing, and shearing. So we are taking the bearing, which is the bearing plate 2.4 into D into T into FU, and for edge 1.2 LC and T into FU. For inner hole 1.2 LC2 T into FU. Tearing, this is the there is no calculation. And shearing, it is shear in the bolt AM into AB into 0.5 ABU. The smaller 1 to 3, we can see we can calculate ASD and LRFD. In the same way, we can calculate the another formula, which is bearing, which is gasket plate. For gasket plate, the internal bolt and external flow bolt. For gasket plate 2.4 into D into FU, we will taking this formula. And the internal bolt will be 1.2 LCT into FU, which will be less than 2.4 D into TFU, and internal also same. And the other formula is given there, and an example is given here. Now we are seeing, now we are doing an example. So let's start. An investigation of capacity of the tension member connected with the figure given below. Use the bolt limit state only. The connection is bearing type connection with the thread. Exclude from the shearing plates, and using 7 by 8 inches diameter A32 bolt, which is standard hold in the plate are A572, grade is 50 steel. So use AIS specification ASD LRFD method. So you can see here the picture is given here. So die is 7 by 4, so DH equal to 7 by 4 into 1 by whole die is given. So 1 by 16 is a constant. If the bolt is dia is given, then we are using 1 by 8. As the whole dia is given, that's why we will use 1 by 16. Okay, let's start bolt. We have using A325, which is FY 90 grade, and FU will to 420. And plate we have been used A572, which is FU equal to 50 grade, and FY equal to 50 grade, FU equal to 65. Okay, let's see. For TN1, the shearing bolt, we can see the shearing bolt. The whole die is 7 by 4. AB equal to area of hole pi by 4 D square by, which is given here. Yan M equal to 4, as we've been seeing the single shear. So if we double shear, then we will use 2. F equal to, we have been found 1 to 4. TN1, we know the M equal to AB into 0.5 FU. For bolt, we have been found 36. And bearing in plate, how we'll get the whole die is found, and thickness of plate is 5 by 8, and FU equal to 65. So N1 to 2.4 DT FU equal to plate, and found 85.31. So in this way we are taking the bearing and plate. So bearing will be plate for inch hole. So inch hole for inch hole, we have been known that DA 7 by 8 plus 1 by 60. This is 1 plus 60 is a constant, as this whole dia is given. If the bolt dia is given, then we are adding 1 by 8. Okay, so LC means the clear distance. So 1.5. So we've been seeing the 1.5. This is the LC1. LC1 1.5 minus dh divided by 2 minus dh divided by 2, which is found 1.03, and fu equal to given, and f tn3 which is 1.2 lc1 plus t into fu and found 50.21, and tn2 which is lc2. How will get the lc2? This is the lc2, distance between two surface, two hole, which is minus dh2 plus 3 is given in question, and dh divided by 2, and this whole and this whole we have been deducted, and found 2.063, and f equal to given, and tn4 equal to 100 point keep per volt. So final result we have been seen tn1 equal to 36, and tn2 is 85.31, and tn3 equal to 50.21 keep per volt, and tn4 equal to 100.6 keep per volt. So the small value we have been found the 36. So after the 36 we are taking the 36 in. So you are using the ASD method and found 72, and by using LRFD method and found 108. So we can say the 108 keep. So if with the final result seen, we can say the after the using 30 keep per volt, the bolt will be fail. On the other hand, we can see the ASD and LRFD method. We are focusing the LRFD method is using the in practically. So we can see that after using 108 keep, the bolt will be failed. So let's see another example. Determine the number of 3/4 inches diameter at 325 bolt is required to develop the full strength of a 572 grade 65 steel plate in figure given below. A portion of the double lap splices connection for at bearing plate connection with the thread exclude from the shearing plane, and use AISC LRFD method to assume the double row bolt with the standard size of the hole. Okay, let's see. As you know the F325, then we will use the FU A725, and steel for steel we will use FU equal to 65. So the plate is given 1/4 into 6, and plate 3, and the middle plate is 3/8 into 6. Okay, so we know that the bolt diameter 3/4 and plate thickness 3/8, and as the area of the plate equal to we have been known 3.2, and n equal to w, and we have been known the area which is 6. 6 is the width as the given in here. Okay, 6 into number of bolt we have been taking 2 bolt, and 1 by and calculating, and plate thickness we have been known 3/8 and found 1.39. AE equal to n equal to 1.59, and AMX equal to 0.85 into AG, and found 1.19. So this is don't need, but we have been calculating here. Phi Tn we have been found 132, and on the other hand phi Tn and found 96. So we'll taking the 96 as the small value. The sharing we have been shown AM equal to AB into 0.85 0.75 AB, and putting one value and found 39.8 keep per bolt. And for bearing we have been used phi equal to 0.75 0.25 FUD into T, and found 40.5 into keep per bolt. So we are taking the small value 39.8. And number of bolt we have been we are known the load is given here 96 keep, and the sharing is 30.9 keep per bolt. So we have found 2.4, and we are taking the large value which is 4 bolt we are needed. So use 4 3/4 diameter at 3 to 4 bolts. So we have been used 4 bolt here, taking 96. So 96 will be divided into two plate, which is 96 by 2, 96 by 2, and the 4 bolt we have been using. So these are our answer. So let's see another example. That determine the diameter 3/4 inches diameter at 36 bolt in standard sizes hole required to the 7 keep dead load and 43 live load on the plate figure given below here, and the 36 steel is used to assume the portion is double lap splices and bearing capacity connection of thread exclude from the sharing plate and the double plate row using the AIS LRFD method. Okay, let's see. As you know, 3 to 5 and 36 when 36 f equal to 36 and fy equal to 36 and f equal to 58, and die of bolt is given 3 by 4 and thickness is given 1 by 4. And as in similarly pi by as plate is given here, 1 by 4 into 10 we have been seen here, and from 2.5 and equal to we have been from 2.4 minus we have been seen here as equal to 2.4 minus 2 bolt. We have been assumed 2 bolt and and plate thickness 1 by 4 and from 2.04. So E equal to n we have been taken 2.06. Okay, or we can calculate another method in n equal to 10. We have been found the 10, the plate is given in 10 and minus 2 into in this way and 2.04. For load factor we know 1.2 dead load plus 1.6 live load and found 77 keep, and phi n equal to phi fy into as found 81 and phi fu equal to a found 90. So the smaller value we have been taking the 77. For sharing we have been use Rn m equal to ab equal to phi ab and found 39.8, and bearing 0.5 phi which is 0.75 equal to 2.5 into f into d into t and found 19.6 kip per volt. So we are taking the smaller value as the we know the small after the attack after the small load is applied, then the plate and bolt will be fail. We are assuming that, that's why we are taking the small value. And number of bolt will be 77. This is the small load, and small load divided by kip per bolt sharing value, and found the 3.9 which are taking the 4 bolt. In the previously we have been seen we have been found 4.2, so we cannot use the 3 bolt because the 3 bolt is the odd number, that's why you are taking the 4 bolt. In this way you are same, we are taking the 3.9 which is the same, that's why we are taking the even number which is the 4 bolt, so we are not taking the odd number. Okay, let's see, this is the example, this is the final. So let's see another example. Determine the design of P for the bolted connection shown in figure given below, and consider the bearing and shearing strength of bolt only, and all bolt are F49 and Fy equal to Fyb is given, and Fbu is given, and the plate are the 36 plate, and F equal to given 36 and Fy equal to given and F equal to 58. Use the AISC LRFD method. So these are the given plate thickness 3 by 4, and this is the 5 into 1 by half, and this is the plate. So the for the tension plate bolt A and B are the extension bolts, so you can see A and B is given here. For the gasket plate C and D are the external, so C and D are external. So sharing capacity RNS M equal to AB equal to 0.4 equal to FU. Okay, so we are knowing the single, that's why the single joint we are using AB equal to the area pi by 4 into d square divided by 4. We have been done the plate thickness when we are known the thickness, so where okay, we have been known the steel diameter of the bolt is given 3 by 4, that's why d square by 4 into 150, and found 26.5. So bearing length, so now we will calculate the bearing strength. The gasket plate we have at first we are calculating gasket plate 2 into d into fu. I will get the d. D we have been known the 3 by 4 is the dia of bolt, and found here, and external bolt for external bolt we have been seen here. The L equal to 1.25. L is the clear length 1.25 half into 3 by 4 into 1 by 6. This is the whole, and found 4.88. So if we go to this here, then we can found the LC value of LC. 1.25 as we have been seen, 1.25 is given here, and minus half is a 1 volt dia, and dia of bolt 3 by 4 in dia of hole is 3 by 4 into 1 plus 6. So gas at least we have been thickness is given 3 by 8 re rn to 1.2 lc into t into fu. Lc we have been found in previous point 88, and putting this below 22, which is less than 39.15. So 22 is acceptable. So interior bolt we have been see LC equal to 2.5. So we have been given here the 2.5 in the interior, and one is half into half. So we can see half into half into half whole into half whole. So 1, and 3 by 4 into 1 by 8 into 1.69. So this is the important, and thickness of cassette plate we have been done 3 by 8. So Rn 1.2 LC is calculating in previously, and FU found 4042, which is greater than 39.15. So we'll taking the smaller value, which is 39. In the same way, we'll calculating the tension plate. We have been seeing 1.2 D into T into FU. So I will get 3 by 4. 3 by 4 is a die of bolt, and half into 58 is given. So exterior and found 52.2. For exterior bolt, we are seeing the LC 1.25 given in the figure 1.25, and half is the one hole, and the whole die as 3 by 4 in 1 plus 8. And the tension plate thickness we have been found half, and RNC 1.2 LC is calculating in previously 0.85 and putting here, and found 29.4, which is the less than 52.2. So we are taking the less below 29.4. In the same way, interior bolt we have been seen 2.5. 2.5 is given here, and one is a half into a half hole into half hole, and die of hole, and 1 by 18 1 by 16 is a constant, and found 1.69, and putting this below 1.69, and found 58.8, which is the less than 52. So which is greater than 50. So we are taking the less below 52.2. So now this is the this is the summary of the result bolt AB and bolt CD. So this is AB and CD. So for sharing bolt AB, we are taking 62.5 as we have been found previously. 62.5 here, 26.5, and bolt CD we have been found 26.5 is the same value. And glass for bearing, which is divided cassette plate and tension plate. So cassette plate AB is interior cassette plate 39.15. So this is the cassette plate. So interior we have been taken the 39.15, and the cassette plate exterior 22 keeps. So cassette plate for exterior we have been taking, this is the cassette plate exterior 22. And the tension plate we have been taking, the tension plate interior is 29.4. So this is the tension plate. So 29.4, and the interior is 52.5. So 52.5 interior. So we have been seen here 26.5 is a small value of sharing and bearing. So 26.5. So this is the sharing and bearing. So all three is value 26, 39, and 30, 29.4. So all three is value we have been seeing the 26 is the small value. That's why we are taking the small value. On the other hand, we have been taking the 26, 20, and 50, 52. All three is value. We have been taking the 22 is a small value. So 22 is a small value of sharing bearing. So that's why we will use 22. Okay, let's see. So PAB equal to A plus B plus C plus D. So total we have been we are adding all value and found 97. For designing we are using ASD and LRFD method, and 48.5 and 72.75. This is the answer. Okay, let's see another example. We use the elastic vector method to compute the result of bolt shear forces in the eccentric load of bolt group of the figure given below. The bolt are the same size. So we can see here the dimension given is the 4 inches, and this is the 5 inches, and this is the 3 by 4 slope, and this is the 6 inches. So due to movement we are taking here, we are taking at first we are dividing in the x-axis and y-axis. So y-axis we have been seeing here 4 by 5, and we are multiply with 10, and in the same way when we are taking the axis, then this will be 4 by 5. When we are taking the vertical, then we will use the 3 by 5. This is the, as we are saying, the vertical 3 by 5 and multiply with the resultant force, and then we will get the axis in horizontal value as well as the vertical value. So we have been found, and that and due to the direct shear we have been the same value as found, and the CG is given here. So we are calculating the CG in our convenient for the calculation of our method. So if you take the moment, so you can know that the moment is a very prominent or formula I have used, which is force into perpendicular distance and plus force into perpendicular distance. So at first we have been taking the moment 8 into 6 into 2 plus 6, 8 is the here is the load we have been found, and 6 into 2 as the we have been seeing, this is the 6 below, and we have been seeing the vertically we have been taking the force is the 6, and the distance will be 4, this is the 4, and 5 by 2 is the another distance 5 by 2, and found 62, 66 keep in C, and distance square will be distance from CG to the bolt. We have been taking the each of the distance of CG, which is 3.61 plus 3.61 plus 3.61, so 3.61, which is 52 inch square. So this is the these are the given. How we'll get the 3.61? As we know the CG, as in the hypotenuse is equal to longitudinal square plus length square. So 3 into 2 is given here. So we can easily calculate it here. Yes, this is the 6. So the 6, the half of 6 will be 3, and the half of 4 will be 2. So in this way we have been found the 3 into 2, and square rooting here, and found 3.61. So we are putting this value and multiply it 4, as the 4 bolt are calculated here. So and then we are calculating Rm, which are m equal to y into summation of d square. So y we are taking the 6 into 2, as we know the given in here, and found 3.81. In the same way we are taking the y-axis, which is m into x into d square. So x we have been taking 4 by 2. This is the 4 distance of between two row of the hole or bolt, and found 2.51. So so you can see here, here the schematic diagram. We have been taking the 3.81, 2.54, 2.54, 3.1, as was all are the clockwise as movement is occurred here. Okay, so direct shear we have been calculating here. So if we calculate that direct shear RBX is force in x direction, we are known the x direction is 8 kip, and divided by number of total bolt. We have been seeing the total bolt is 4. In the same way we calculating the direction in y direction, the load is 6, we have been seen here, and number of total bolt is 4. So we are found 1.5. So if we calculated in here direct shear, the in horizontal and horizontally and vertically, we are dividing here. So now we will calculate the resulting bolt in shear. In bolt A, R equal to root over AMX into RX AM A, and A B, and second one third one is C, and fourth one is D. And calculating one, and found 5.31 for A, and 7.08 for B, and 4.43 for C, and last one we have been found 2.09 for D. So maximum is found for B 7.08. So maximum share is occurred B is 7.0. So this is just our answer. Okay. So we can see another example. It is taken from pop-up books of pop-up, or it is taken in 2 semester with solid mechanics. rebate joint. This is the rebate joint, so we cannot confine that this is the bolt joint. So rebate joint is given below. Find the maximum shear stress, tearing stress and bearing stress and allowable stress 20 and 25 and 35 respectively. Check the check here. So we have been seen here. So 50 is given here. The each bolt is taken 50 into, as we've been taken 50, and the 5 bolt is given. That's why divided by 5 and 50 keep per bolt. Sharing in each table, P by P is given and D is given is 0.80 is our dia of bolt wall dia, and found 19.09, which is less than 20. So okay. On the other end, we can see another tearing or sharing, tearing or tensile stress in row 1. So this is the row, this is the row 1 and this is the row 2. So row 1 I've been seen P by A into D into 2 divided by D minus 2 into 2 into whole, as the 2 whole is given here, and found 10.02, which is less than 25. So okay, tearing is the row 2. We have been found P into P divided by T into D into 3. Why the 3? Because the 3 whole is given here, so that's why we are multiplying 3 into whole, and found and then found 6.92 kips. Okay, so bearing we can see here P by T into D into dia of bolt, and found 20.8 kips. So this is okay. So this is the example we've been seeing. The rebate, we can see in the rebate or bolt joint is the lap joint and butt joint. There are two type of joint we can use. The rebate or bolt joint, the shear stress occurred in bolt, and tensile or tearing stress occur in plate, and bearing stress occurred between bolt and plate. Okay, so here is a find the resultant of weld. So we are not using weld bolt. Okay, so we can use the so we can use the resultant having the bolt. This is also taken for SM2 or pop-up books or semester 2, figure given below here. So P into PX and PO into EXY. So we have been seen 48. So we are dividing axis and y axis all the bolts as, and found Px equal to 0 because the x axis is there is no distance. On the other hand, y axis, if the bolt is y axis, then the distance between y is taken the 4.5. This is the 3 and 4.5 we are calculating here, and found here as summation of x square y square. We know the number of bolt, and this is x square, and number of bolt this is y square, and in this way I found 263. And PTX we have been found T into summation of YMAX. YMAX is equal to 4, maximum distance we have been found, and PY equal to X, maximum distance 4 been found. We have been seen the maximum distance as a 3 and 1.5, which is the 4.5. And now PDX equal to PX divided by N equal to number of bolt. How many bolt we have been seen here? The 12 bolt is we have used here, that's why divided by 12. And PDY equal to same way will be used divided by 12, as the total bolt is 12. And the resultant in same way, PT root over PTX into square root of PTX into PTX is square plus PDY plus PTX, and in the same way we have been found 7948 pound or 7.9 kip. Okay, so lecture is so much lengthy, so I'm just covering only bolt connection design. So in the next lecture I will deliver the weld connection, how I will design the weld connection in the steel structure. So if you have any question, then let me know, and you can what I will say, you can ask me, you can comment me or mail me. Okay, thank you everyone for your patience.